It's all cool.
Okay, let's get started. So our agenda for today, and this is the key point of it, choosing the right tool for the right job. Many times, customers say, I need an HSM, and my job is to help explain the landscape and stop them using cloud HSMs. We're then going to talk through some of the fundamentals of the cloud HSM service and some of its recent features. But again, as Avni said, we don't want you to use these things directly unless you have to. What AWS Cryptography tries to build is services that hide the complexity of the HSMs for you. We have a bunch of related sessions. Have these all been now, or some of these still to come?
I think some of these are still to come. So Secrets Manager should be coming later, and KMS is later today as well, I believe.
Okay.
But they will also all be on YouTube, so within a couple of days, you can grab any of these sessions online.
Okay. So Avni is the product manager for the Cloud HSM service. My name is Squig. I'm a principal security SA. I spend my entire life now in financial services because it's difficult, and financial services have big challenges with regulations and security, and it's my job to try and help them. So first of all, AWS Crypto, selecting the right tool for the job that you have. We give you a range of options, and everything about AWS is about control. We want you to use a service where we're managing most of the stack for you. That lets us patch it, it lets us run it, and in return you get a simple to use API with all the nice AWS integrations. And then we go through a spectrum that takes you to, I want full control of this. I don't want Amazon to have any role in this, for example. I want to do it all myself, but I need you to handle the hardware and the racking and the provision of the service to me. Cloud HSM sits on the right of that picture, and KMS sits on the left of that picture. And then you get to choose what's right for you and your organization and your requirements. So the key AWS crypto services, hopefully many of you that use our platform are familiar with them. So we have the key management service on its own. This is the main one that underpins many things we do. This is the service that makes it super easy for you to pick virtually any AWS service now and check a box and say, encrypt my data. We have AWS Certificate Manager, Private Certificate Authority, which helps you build and run your own PKIs. AWS Secrets Manager, which is somewhere for managing your secrets, a secrets vault, if you like. And then we have the Cloud HSM service and all of its raw terror and capability when you need something that does PKCS 11 or equivalent. So let's look at each of these quickly. The main thing is this: the root of trust in all of these services is an HSM. The difference is, with KMS, those can be HSMs that we manage. With Secrets Manager, we manage them. With PCA, we manage them. With Cloud HSM, you manage them. But the entire thing is, when a customer says, I need an HSM, well, you can use any of these services then, because all of these services are based on HSMs. Let's look at the first main use case. I want to encrypt my data in AWS, sign things on AWS. So AWS KMS. The main launched service has AWS built and operated FIPS 142 level 2 HSMs. They've got a bunch of level 3 characteristics around physical security, for example. But these are general purpose HSMs that we built ourselves that can run at the performance and scale that we need to be able to run at, to then offer all of these other AWS services easy access to go and get data keys to encrypt customer content with AWS Identity and Access Management, wrapping it from a control plane operation point of view, and AWS CloudTrail giving you logs of all the activity that happens. So It's really simple. You create keys within the service. Your keys have policies that control what can happen at the key side, and then you use AWS Identity and Access Management to control what happens at the calling API side. We then added a feature called Bring Your Own Key. So with the native service, you say generate a key, we generate a random number within our FIPS boundary, and that becomes a customer master key. Some customers said, I don't like your random numbers. I've got better random numbers. So we give you the option to generate your own keys on premise and upload them into the KMS service. The difference is at that point, if we ever lose the keys in KMS, say there's a power failure, these things are in memory, when the service comes back up, you have to go back on premise and find that private key and re-upload it to the service. So you trade off durability management. We're responsible for durability with the native service. With BYOK, you take a stake and your key's been durable for a long time. And then some customers said, no, we want our keys in our own HSM. And when we launched CloudHSM version 2, which is a much more agile service than the CloudHSM version 1 service, we then connected these things together so that now you can have the easy-to-use KMS API at the front end, but your cryptographic operations happen in a CloudHSM in your AWS account. So again, you've taken more control of the back end. You're still responsible for durability, but the CloudHSM service makes durability easy. You can create clusters of HSMs. They back up to Amazon S3, which has been designed for 11 nines of durability. You're unlikely to lose your data. No, I said unlikely. There's still a responsibility by you. But what it means then is KMS offers a full spectrum of things for you. You can use our FIPS 142 level 2 HSMs. You can use your FIPS 142 level 3 cloud HSMs. Some customers tell me they have a level 3 requirement. And in that usual way, we launched at level 3 and a customer come back immediately and says, well, I want level 4. Are we doing a level 4 HSM? Oh, shh. We just launched a really wonderful new feature 2 weeks ago in KMS, which is asymmetric keys. Traditionally, KMS was symmetric keys. We use a CMK sitting in the HSM to wrap data keys. The data keys can leave the service in plain text, and then the AWS service, or indeed your own application, can use those data keys to encrypt the data, throw away the data key, come back and get it from the KMS, and unwrap it from the KMS service when you need it. With asymmetric keys, you can now generate public-private key pairs within KMS that can stay in the service or can be exported. RSA and elliptic curve keys, and the API now supports sign and verify as well, for example. So much more flexibility for you to use these things within your own applications, use them for code signing and many other purposes now as well, fully supported by the command line tools. Again, all of these keys are generated and are stored in our FIPS 142 HSMs, the same ones for the KMS service. When you need to think about cross-region replication, some of our customers operate globally. Some customers choose to use different regions for different purposes. One of the tenets of the KMS service is that your keys don't leave the region. You know, if you think of everything we talk about at AWS, you select a region and your content stays in that region. But we offer S3 regional replication, for example. So what you do is you unencrypt the data in one region, pass it over a TLS connection, re-encrypt it in the next region, for example. The AWS Cryptography Software Development Kit allows you to do much of this at client side, and with key rings, you can have multi-region key rings, for example, as well, and help you solve some of these problems. For me, who's not a cryptographer, doing multi-region cryptography and things is absolutely terrifying. The purpose of our crypto tools is to make these things much easier for application developers to consume in their own apps. Which moves me on to the SDK. So this is software tools built by the AWS cryptography team. So the team writing the code for these HSMs and these services writes a really nice SDK that you can integrate into your own applications. There was two things I was always taught: don't write your own crypto system and don't write your own authentication system. This gives you the full power of AWS Crypto sitting in your office writing code with you. They've got an SDK that they update. It's on GitHub, so you can review all this code yourself. But it makes it really easy for, let's say we've got a simple application that writes data to a database. The Crypto SDK can allow you to say, pick these 3 fields, encrypt them using AES 256, and then store the data in the database. And if you're hot with modern privacy regulations like GDPR, the new stuff happening in California, Brazil has this happening as well at the moment, where encryption becomes really important. This helps you do that very simply. That's the kind of thing people would have used an HSM to do in the past. You passed it to an HSM and done it. The performance could be woeful. This is running on your EC2 instance or even on premise. Very quickly, it can do things like data key caching at the client side to do these things very quickly, but you've got the full security of the KMS HSMs sitting behind it. Avni, I'm going to let you take this slide because you're the migration PKCS11 expert.
Thank you. So a lot of times when customers come talk to us and say that they need to use CloudHSM, we're asking them why. Right? Many of you are in this room because we have met and we asked you to come here. The cross-region DR that Squig talked about is one aspect of it. Very often we see lift and shift applications. So traditional HSMs, you write the applications using a PKCS11 SDK if you're coding in C or a JCE SDK if you're coding in Java. And it's a familiar environment. You've got your application. It feels like you just want to lift that code, put it into the cloud. And because KMS doesn't speak PKCS11 or JCE, it speaks the encryption SDK, you feel like CloudHSM is your only choice, which may be the case, but when you're using PKCS11 or JCE, in exchange for the standard programmatic interface to crypto, you are giving away all the power and flexibility of AWS Identity and Access Management, IAM, roles, policies, metadata, tags off, right? That's what's encapsulated in the encryption SDK, which is also available in C and Java and Python on multiple languages and open source. It is specifically designed for encryption and decryption operations only. And it is a tightly scoped, well-designed SDK for the specific purpose that you're actually using the HSM for. Right? And so when you're making the trade-off between should I use CloudHSM without changing my application, or should I use KMS after changing my application, I want you to consider the full spectrum of what's actually going to be more work. Right? Is it more work to rewrite your application once and then track all your operations in CloudTrail, monitor everything in config, assign IAM resources and policies, rotate your secrets automatically, not have to worry about application integration for anything? Or does it actually make sense for you to continue using your PKCS11 or JCE library, and in doing so, choose to use CloudHSM? There are genuine use cases for both, right? So if you're doing transparent data encryption where you need a drop-in PKCS11 library, if you're not migrating your data to an Amazon database, chances are you don't have a choice. You have to use CloudHSM. But at least ask yourselves the questions, not just from a compliance and a day one architecture perspective, but also to your DevOps team. As you have to rotate your data, as you have to monitor your workloads, as you have to scale, be agile, fail over, shift regions, move to new regions. Is this the right long-term choice for your application?
Thank you. Okay, let's look at our next use case. So I need to create a PKI to authenticate internal servers or indeed devices, for example. So part of Amazon's certificate manager we call Private CA PCA. This makes it super simple for you to stand up a full PKI on AWS and use it for your purposes on the cloud. 20 years ago, I built a PKI, and it was a Windows server that stayed in a locked cupboard, and you had to pull it out now and again issue certificates. And this is how far we've came. So you can issue certificates down to devices. These might be IoT devices. And maybe your on-premise servers. Maybe you're replacing your PKI that's on-premise. You can just stand it up in AWS. You can always connect everything on-premise to everything on AWS. Or you may be using this in your instances. You maybe are using internal application load balancers, for example, or network load balancers, and you want to do TLS internally using known certificates. This is the service that makes all of that really simple for you. The back-end HSMs for this are cloud HSMs. The price of this is magnitudes less than running your own cloud HSM cluster, because the service team is able to make multi-tenant use of things. So I think it's $400 a month to run your PCA PKI, and that's running on a resilient and durable set of HSMs. If you were building a PKI based on cloud HSM, you would probably be using 2 cloud HSMs for resilience at the front end. That's you up roughly $3,000 per month as a starting point. And then you have to build and manage all your PKI software. PCA now is full stack, so you can create your root on AWS, you can define the purposes, you can scope these things down for the organizational names that you permit. One of my customers as a bank, for example, says we don't want an internal people able to create a google.com PCA and then fill an application and mount an attack, so it includes all the functionality you need to do that. It then, more to the point, includes full AWS identity and access management integration so that you can segregate the duties of the different teams, the team that looks after the root, the team that looks after the subordinates, who can create the certs, who can distribute them. All of that is easily controlled by you using our familiar policy language for identity and access management. There's been a lab on, I'm not sure if it's repeated again, that Ramani is running here, which is based around PCA and setting up your first environment and building all those segregations of duties. You can easily use this cross-region because you can have your root CA in one region and then use that to sign requests from a subordinate in another AWS region as well, for example. So, we can have a root owned by the security team. We can have them subordinates within our business units, for example, and federate it all out really, really simply. The benefits of this is a fully managed service. You don't have to patch it. You don't have to worry about vulnerabilities because we're worrying and fixing vulnerabilities in it, for example. As we add new features to our service, those features magically pop up in the management console for you. You don't have to migrate. You don't have to do anything. It's really simple now to automate the creation of certificates. One of my banking customers has a lot of human process around distributing certificates that ties them in knots. And one of the benefits they see out of this service is they can make lots of that self-service, but they've got the right segregation of duties and controls, and they can monitor it using CloudTrail and other things to make sure that everything's working. So they get to implement their policy, but they're managing to automate their implementation by delegating things down to development teams to automate stuff on their behalf. And then, like everything in AWS, pay-as-you-go pricing for it. Let's look at our next use case, a really important one. I want to manage the life cycle of secrets. All too often in the world, people hard code their secrets into applications and then act surprised when their secrets get compromised. AWS Secrets Manager is our solution to this. You don't have to install any software. You have a service that allows you to store secrets. Those secrets are encrypted using KMS keys that you control. So that can be any of those KMS options that we talked about earlier. You get to control access to those secrets using really fine-grained policies. And then here's the icing on the cake. It includes a rotation of secrets for you. So you have a secret to access your RDS database from your application. You could rotate that every night using a Lambda function. We've got a bunch of examples. You can write your own where you are constantly rotating and moving your secrets forward. And you can scope then the lifetime of your secrets down to really small values so that on that day the worst thing happens, the time that you might be exposed can be as short as possible. Much of this came from things that we needed to build ourselves as much as our customers telling me we need a service like this. We had AWS Systems Manager, includes a thing called Parameter Store, you may have seen, and people were using that to store secrets. It also encrypts. Parameter Store originally was more for your environment variables. It doesn't include things like key rotation. Secrets Manager is targeted exactly like this use case. Your application starts up, it calls the Secrets Manager API using a role from an EC2 instance, safely retrieves the current secret, connects to its database, gets on with its life. For example, every time a secret is modified or accessed, you get an AWS CloudTrail record of that you can look at and look at patterns of activity around it as well. And remember, because all of this stuff is integrated with CloudTrail, if you've turned on AWS Guard Duty, and all of you should turn on AWS Guard Duty is now monitoring your CloudTrail logs and saying, hey, something really unusual just happened. So the day that a secret is misused from an unknown IP address, AWS Guard Duty is going to pop up and say, something unusual happened in this API, you should have a look at this. And this is where this stuff comes together, you know, as we look at the detection response that you get out of the back end of it. Really, really simple to use. This stuff has a really big focus within our service teams. We're really listening hard to what customers want to bring these things on. I must say, sorry, to pause for a second, keep us on our toes. As you look at these services, tell us what you want them to do next, because we're focused on your requirements. Do that through your TAM, your AWS account manager, by emailing any of us, for example, and we take that feedback and look at what we need to build for the future. Given all that, hopefully you've now seen that there's an AWS crypto service that meets the need that you have. You don't need a Cloud HSM. No one needs a Cloud HSM. And if we've met your needs now, you're allowed to leave and go to the pub early, or maybe just for a juice. Now, on our last use case, if that still hasn't met your needs, and you need direct access to the full power of a FIPS Level 3 HSM, then Avni is going to now take over and cover that, because she loves her HSM so much.
I love my HSM.
And as an SA, I don't go deep enough on this stuff.
It's all good. The only thing I was going to add is the one thing that you should not use Secrets Manager for is to store the passwords to your Cloud HSM cryptographic users. I kid you not, I have requests for CloudFormation templates and automations and SDK automation where you can take cryptographic user passwords and store them in Secrets Manager. And of course, having lived through the first half of this talk, you know my question's going to be, why are you using Cloud HSM at all? Well, because we don't think KMS is safe enough. Well, you know, why are you storing credentials to your HSM in KMS? Well, we're not. We're using Secrets Manager. Well, Secrets Manager protects it using KMS.
Someone left.
That's awesome.
Someone left. We've won. Two people
So
have
just
left.
the point of all of this is be cognizant of the threat model that you actually have, and also be cognizant of how easy it is to inadvertently create security issues or security errors that you're in fact trying to avoid as you use Cloud HSM, right? The reason you're using Cloud HSM is because you need control or you want control. You want control over the algorithms. You know, admittedly, KMS, Private CA, Secrets Manager are special purpose services. So if you need HMAX or key derivation or blockchain, actually blockchain is supported in KMS now, but you know, some of the key derivation, for example, SSL offload, you are going to need a general purpose HSM with the full flexibility that Cloud HSM offers. But if you don't need that control, then you can use the other managed services. Generally, you'll also use Cloud HSM because you need control over your users. You explicitly want to be outside of AWS IAM because you don't want to have AWS managed identity in the HSMs that store your corporate secrets. That's when you would use Cloud HSM, right? Now, the flip side of that is if you were to lose your credentials, I can't help you. There's no paper that you can sign that allows me to bypass and reset the passwords on the HSM on your behalf. The best I can do is save backups for you, and you can restore a cluster from there, right? So if you've accidentally changed a password and fat-fingered it and don't remember what it is, you can go back to an old password, but if you lose your cryptographic officer passwords altogether, that cluster is gone. We can't help you. But you're choosing that control when you choose an HSM. The HSM also gives you control over application development. need control over threading, control over application languages, where your apps live, how they're used. All of that, you have much more flexibility with a general purpose HSM. Now, with that control comes an immense amount of responsibility. So for those of you who raised your hands, about half the room who've managed HSMs on-prem, you know that provisioning can take 2 to 3 weeks. You have to do key ceremonies. You need to clone them into groups. You need to make sure that the load balancing is working. You have to redefine all your clients. You have to redeploy all your clients. If an HSM fails, you have to go through that entire process again. When you have to update firmware to add algorithms or patch security issues, you have to take each HSM down one at a time, SSH into it, update the firmware. Sometimes it doesn't work, roll it back, see what broke, try it again, and it can take a really long time. Backups are a significant responsibility when operating your own HSMs. These HSMs are designed to lock out if you enter the wrong login, for example, a certain number of times, which means if you've rotated a secret or a credential and it didn't propagate, you can take out your entire cluster within a couple of minutes. And if you don't have that backup, you've lost all your keys. So manual backups was another issue that our customers with traditional HSMs were really struggling with. And then, of course, the app integration and the user management. So when we built CloudHSM, as with all things AWS, we have tried to take care of the undifferentiated heavy lifting for you. So with the new CloudHSM, high availability is automatic. If you add an HSM, if you remove an HSM, your application will automatically detect that change in config and change the way that it does load balancing. If the network in a particular availability zone is slow, it will automatically rejigger the traffic as well. If we see that an HSM has failed or isn't responsive, we will flip it for you, and your application won't even notice. Provisioning is also automatic almost. You can click a button in the console or run a simple CLI command. We take care of all the cloning, all the synchronization, everything for you. It takes about 5 to 12 minutes for an HSM to spin up. If you don't need the HSM, you can delete it. The HSM saves state. You don't have to be billed for an HSM you're not actively using. We take care of all the maintenance on the HSM. So the firmware upgrades are transparently handled for you. Again, your application will never notice as long as you have 2 HSMs across 2 AZs. It'll just transparently switch over to the new one. You might see a snap in sessions when one HSM goes away and another one comes back. But as long as you have retries built into your app, you'll see a momentary increase in latency, and that's pretty much it. We take care of backups for you as well to a certain extent. So we can't see what you're doing on your HSMs, which means I don't know when you've changed a password or added a user or created a new root CA or a new subordinate CA. But once a day, our service will automatically take a backup of your HSM for you. You can also force a backup to be created by adding or deleting an HSM, and that way you can have a snapshot after a major mutating change. Application integration remains your responsibility. We provide C and Java SDKs, OpenSSL. And user management, again, remains your responsibility. So cryptographic officers, cryptographic users, quorum, policies, passwords, all of that is entirely up to you. And it's handled through command line utilities that we vend to you that you run on your end. So the other question I frequently get is, why don't you have AWS SDKs for creating users? We don't, because by definition, you don't want it when you're using CloudHSM, right? So we deliver in CloudHSM single tenant FIPS 142 level 3 HSMs in your VPC under your control. We have zero config high availability. We have audit logs and HSM metrics, but these are not in CloudTrail. Right, I'm going to pause for a second and let that sink in. Because AWS cannot see your transactions with your HSM, the operations you conduct on your HSM will not show up in CloudTrail. What you'll see in CloudTrail is I created an HSM, I deleted an HSM, I copied a backup to another region, I deleted a backup, right? The metrics that you will see in CloudWatch are things like I have these many sessions connected to the HSM because we can see connections open to the ENI, that you have so much memory available on your HSM, and so forth. But we cannot show you what you're actually doing on your HSM. We don't know how much your HSM is loaded. We don't know how, what kinds of transactions are happening there. What we can provide is the audit logs that the HSM generates, which capture all the management functions in terms of, you logged in, you logged out, you wrapped a key, you generated a key, you shared a key. Those are delivered from the HSM not to CloudTrail, but to CloudWatch, into the account that owns the HSMs.
Can I add a little bit just to because some of you may still need an HSM and be wondering why you can trust Amazon to provide your HSMs. What actually happens when you provision this is the HSM comes up, your client comes up on your EC2 instance. Remember, we can't see inside your instance. That's private, it's yours, you're responsible. That client then creates its own tunnel across the AWS network path to the HSM, and now you've got a secure tunnel from your EC2 instance into the HSM. So to everything underlying we've got, that's now invisible. You know what I mean? So you've got an HSM running your stuff, and you've got an EC2 instance running your stuff, and a cryptographic tunnel across our network so that there's nothing we can get in the middle of. You're validating that you're connected inside your HSM with your own connection at that point. We've got no stake in it, so hence we can't see it. So if you're, again, wondering how we can do FIPS level 3 and do this stuff for you, these are the reasons.
So while we do a lot of the undifferentiated heavy lifting for you, you're still responsible for the development and integration. If stuff is broken on your app, remember that we're trying to debug a black box, right? So you'll see us asking for sample code and client logs and asking you to try something and try something else, see what happens, so that we can try to figure out what's wrong with your code. We can't directly see any of it. Performance is also your responsibility, making sure that you've optimized your application, optimized your architecture, and that you've multi-threaded and loaded your HSMs enough that you can get the most throughput from them. User credential management, any key management is all your responsibility, and then monitoring and scaling, making sure you add HSMs when throughput is necessary to be increased is also on your call. So to summarize the options you have in crypto, right? Again, you can use the HSM bare metal, so to speak, with CloudHSM. Or you can take advantage of management layers that we've built for you so that you have more elasticity, scale, availability. You don't have to worry about all of that. And so that you can take advantage of AWS monitoring, AWS policies, AWS control. One may be right for you, the other may be right for you, but we want you to be aware of the complete spectrum of choices you're making. With KMS, Private CA, and Secrets Manager, your secrets are stored on AWS managed hardware under AWS's control. So you can still read our SOC controls, you can read our security policies, you can see how the device, how the service is implemented. But at the end of the day, you're trusting us to handle this work for you. With CloudHSM, for better or for worse, all that control and all that responsibility is yours. Similarly, the operations, as we talked about, are logged in CloudTrail because these are all control plane services. For CloudHSM, it's inside the data plane, which AWS can't see, so you have to rely on your application or whatever the HSM provides to you in CloudWatch. CloudHSM is not natively integrated with AWS services. For that, you have to rely on KMS or some of the other services. You do have somewhat of a middle ground if you use custom key store, which is KMS connected to CloudHSM in the back end. With the managed services, you have an AWS CLI SDK. With KMS, you also have the encryption SDK. With CloudHSM, you have industry standard PKCS11 JCE OpenSSL, and then Windows CNG KSP. Rotation has to be managed by you with CloudHSM. With everything else, except for KMS BYOK, we will take care of rotation for you as well. And then lastly, there is a price. I think security always tends to trump cost for most of us, but we do want you to be aware that you have a fixed cost with CloudHSM because you need to have at least 2 HSMs just for any basic production cluster.
It's $1 per key in KMS per month. It's virtually free. It's virtually free.
It's actually almost $1 per key in CloudHSM too. We have a capacity of 3,300 keys.
If you use it then. So to get your bang for your buck, stuff it full of keys. Here's an interesting segue, because I got a question the other day saying, can I create a RAID 10 array of Cloud HSMs? We have an internal version of Stack Exchange we use to help each other. And some solution architect got from a customer, well, the customers get thousands of keys to store. So they want to create this big cluster of Cloud HSMs to store them. And by the 7 minutes it took me to get to that answer to say, what on earth are you doing? 10 other AWS people had replied, well, you use KMS. You get the private key from the customer. KMS generates a data key. encrypt a key, store it in Dynamo, S3, or whatever. Why would you need to store those things in a CloudHSM when KMS can wrap that data and do it for you? And it's a good example of when you're faced with these challenges that look like they need a CloudHSM, pull yourself back and look at the problem and look at the things available. And there might be a very cheap and performant way of doing that.
Yeah. So I'm going to do one more spiel of CloudHSM versus KMS. This is the last aspect we want to bring home to you. And this has to do with the capacity of the backend, right, and the responsibility for the scaling. So if you're using KMS with custom key store, where you're benefiting from the front-end integration of KMS with all the other AWS services, but you're generating and storing your keys and using them from a CloudHSM cluster that you control. To some extent, that gives you the best of both worlds as far as integration and security is concerned. From an availability and scale perspective, keep in mind that you have to make sure that there are enough HSMs in your cluster to handle peak load, even if a given availability zone has an outage, right? So your worst case scenario is that you're at P99 load and an AZ goes down. You have to make sure that you have enough HSMs in your cluster to handle that worst case scenario. Whereas with KMS, with KMS, we have a massive fleet of HSMs already sitting there and running for you, right? So the availability, the scale, the elasticity is taken care of for you. Now, you may hit throttle limits, but those are generally soft limits, and we can adjust those for you. The amount of planning and reaction time it takes to scale with KMS is generally simpler than the time it takes to scale with CloudHSM.
And remember how you recognize these things in the management console. KMS is a regional service. You don't have to worry about availability zones. When you use CloudHSM, it asks you about availability zones, and that's your good way of thinking. Am I responsible for resilience, or is AWS responsible for resilience? When it's a regional service, we're running everywhere in that region with the capacity to take AZs going down and not hurt our customers. And AZs going down are not things that happen very often, if ever. However, you should still plan on that happening, because we never promise you that these things won't happen.
The blast radius from loss of HSMs is really, really high. So be careful with that. All right, so with that, we're going to dive into some of the specifics of CloudHSM. This isn't the power user session. We do have different sessions that are recorded online, but I want to give you a sense of how CloudHSM works, right? So all your HSMs live inside a cluster. A cluster is a regional construct. Your HSM instances, again, are single-tenant instances in your VPC that live within the context of the cluster. Every HSM within a cluster is synchronized with every other HSM in the cluster. We manage that synchronization for you. So if you create a key in one HSM, it's going to be replicated on all the others as well.
Dwell on that. You're designing large, complex architectures. They sit in a VPC. Hey, VPC's got transit gateways, it's got peering gateways, it's got all sorts of ways now where you could create a central one in an organization and share it out using the AWS native networking features as well, because it's just an ENI in a subnet, and you can start routing to that using transit gateway and other things to make this really super simple from a connectivity point of view.
Absolutely. The way that this magic works is we create backups. Backups are a unified snapshot of your HSM, not just the keys, but also the users, the policies, the certificates, any quorum, any sharing that you may have. The backups are protected with a key called a masking key that is generated in the cluster when you create it for the first time, and is only used within the HSM by the firmware for the explicit purposes of cloning and backups. When you create clones of HSMs, essentially copies of clusters across different regions, this masking key is the same, and a lot of the magic of the synchronization works because of the masking key. Because all HSMs are the same, if you need additional key capacity, you're going to create additional clusters. But if you need additional throughput, additional transactions per second, you can add HSMs to your cluster. The concept of a cloned cluster is when you take a backup, so this is an image of one of the HSMs, and create a cluster from that backup. You can use this to have identical clusters across regions. You can also use it to enable CloudFormation to spin up new regions, new containers, and so forth. Creating a cluster for the first time is a manual process. There is no automation because generally you have to do a key ceremony to claim the cluster for the first time. But once that's done and you have a backup, you can leverage these backups to simplify your automation. And then any HSM that shows up in the cloned cluster is going to have the same identity characteristics as HSMs in the original cluster. The service doesn't know that these are related, but you do. And so you have flexibility in things like cross-region DR, where, again, I'll defer to the deep dive talk, but you have a variety of tools available to securely sync keys across regions or across different applications if you choose to use cloned clusters. So when you use CloudHSM, the only time you're using the API itself is over here when you're managing your cluster. And again, these are the calls that show up in CloudTrail. When you're managing your HSMs, you're using CloudHSM Management Util, which is a command line utility that works in interactive mode. You have Key Management Utility that takes care of the high availability and load balancing. That is a simple way to do key operations. We have the SDKs, PKCS11, JCE, Windows CNG, KSP, and an OpenSSL engine that you can use to build various applications. Whether you're using Key Management Util or one of the SDKs, underneath you're using the client daemon. This is a process that's continuously running. It's checking the status and configuration of your cluster. It's keeping track of your login status. It is migrating, it is load balancing across all available HSMs as well. Anything that goes through the client is end-to-end encrypted between your EC2 instance and your HSM, as Quig mentioned. Only the control plane is visible to us. Only that is logged in CloudTrail. Everything else goes over the data plane, end-to-end encrypted, and we can't see it. We also can't influence it, right? So your keys, your key attributes, any latencies, any throughputs, any failures, any absence to perform is all in that end-to-end connection that we can't see, right? What that means is that any compliance is owned by you, because we have no control or visibility into, is your password strong? Is it taped to a sign on your, on your coffee room cork board? We don't know. Therefore, you will generally see, if you ask me, is CloudHSM FIPS validated? The hardware is FIPS validated. The service is not, right? The service lives in the control plane. It doesn't touch your data. It is out of scope of compliance. The HSMs that you are using in the data plane are FIPS validated, and your application may choose to be FIPS validated as a result of how you use those HSMs. Are there any questions on compliance, scope, responsibility?
Yeah. So clients I've worked with work for a European government and investment banks, and their specific use case for CloudHSM is because of the Cloud Act. So let's say Donald Trump wakes up in the morning and he wants all the Swiss banking data. Then the NSA could apply for a court order and a gagging order. If their belief is that in that case, you could technically say, well, here's the keys, here's the encrypted data, but when using a CloudHSM, because you don't have access to the device, you can't do that. Because if that was to happen, we'd be exporting customer data outside the EU and breaching the GDPR.
That's fair. So the question is, for those who could, there are European regulations and other concerns where, one government may request access from AWS to your data. And is the protection profile any different from CloudHSM versus KMS or one of the other services? The short answer to that is there is no tooling even in KMS for us to have any access to your data. We don't know what you're encrypting. We don't know where certain records may be. But the long answer is let's sit down between your team and our compliance folks, and we can give you the actual technical and legal language that you need to fulfill those mandates. We don't believe that there's any difference on either side. We recognize that your risk profiles and your interpretations may be different. That's why we built CloudHSM, so that you can choose the risk and control that you're comfortable with as you move your workloads into the cloud.
Let me add something to that, because my job is working day-to-day with large European banks. Lots of them have been through their due diligence here, and lots of them are using KMS natively, not even uploading their own keys. So you always have to make your own risk decisions. As Avni said, we can't extract private keys from KMS. They sit in HSMs, and we've not built the tools. And our current thinking and position is that no one can force us to build the tools. And this is always a good conversation in Europe, and there's one I always welcome with my customers. It's not one we shy away from. You're traveling on a path that many have traveled before you now, who have very similar fears and risks. And they're getting over these things, and they're using us, and they're using KMS.
Yeah. So,
Did you mention that you could change, like, because you had KMS and I'm using your KMS system, that you could change a password if I didn't know my password? And so if you have the ability to change the password, but you have the ability to secret text, that's something.
no.
No, so let me put that in perspective. You're an AWS account owner, and you lose your AWS account credentials, and you beg AWS support to let you back in your account. They've got a process to validate that and then restore access to your AWS account. And your AWS account is the thing that calls those APIs. Those private keys in KMS sit in HSMs that your account controls. Yeah? So, again, because it would be unacceptable for our business if you lost your root keys and you never had any IAM users and you went, I can't access AWS anymore. So we have a process in AWS support that helps restore you access to your account that involves us going through quite a bit of process with you to validate that it's you, for example. So that's what we mean. That's restoring access to your AWS account. It's not giving access to the HSMs where your private keys are.
Yeah. You had a question?
Yeah, so you said you could restore to a previous version if we had fat-fingered a password, right? However, let's say a government regulation has a previous version, but we've already moved on, and they request you to restore back to a version where the information that they possess is now applicable.
So you can delete backups. While we take the backups for you and store them for you, you can delete your backups at will, both through the API and through the console. In fact, we explicitly recommend that you go ahead and delete backups when you rotate credentials or when you've rotated keys. Once you've deleted your backups, we don't store any other copies of them anywhere.
To slightly address.
I'm going to finish the thought.
Oh, no, yeah.
The other aspect is even if we were to use the backup, let's say to restore an HSM, it's still protected with the same credentials that you set them up with. So you would still have to brute force a password. Every time you got 5 passwords wrong, the HSM would zeroize, so you'd have to reinstantiate it, which is 15 minutes. And then, think about the time and the trials required to brute force an 8-digit minimum password. It's not easy to break into an HSM. Right, it's the same thing as if the HSM were out on the street and someone were trying to pound on it. It's the FIPS validated security policy that protects it. But go ahead.
No, you finished answering it. That was perfect.
Are there any other questions? Yes. Yep. So the question is, how do we add additional curves to CloudHSM, and what's the timeline for those? We operate our HSMs in FIPS mode today. So the algorithms that we can provide are the ones that are approved by NIST. As NIST retires algorithms, we are required to remove them from the HSMs. Once NIST approves new algorithms, we can add them to the HSMs. So an example, ED25519. It's used pretty frequently in IoT. It's almost approved by NIST, but not quite there, and so we're waiting for them to do the final approvals before we can put it into the firmware and roll it out. And so that's going to be a limitation that we have. Did you have a follow-up? Okay. Any other questions? Yes?
Do you have anything in the roadmap for in-memory encryption? You said that nobody can get into your compute instance, but what if we don't trust them?
Then you do the encryption on the HSM.
Okay, but at some point I will have to encrypt it, process it.
Unfortunately, such is life.
So I would encourage you to look at the replays of the AWS Nitro sessions, which is our latest hypervisor, for example. The Nitro hypervisor has an API to EC2, so that when you call the EC2 service and say create instance, reboot instance, do these things, it calls a Nitro API on the back end of that thing to tell KVM-based Nitro to go and do something. That API doesn't include dump memory. You know, we can't access the memory on your EC2 instance. It's your physical memory. We're always looking at these things, and customers ask for these things a lot, and AWS Crypto cares about it. It's a small edge case that we're not sure helps you. I'll be honest, you know, we announced something the other day, and it's now up on the website that you can look at called AWS Nitro Enclaves as well, for example, which is another way for customers to do some careful and private things on top of the platform.
Without relying on the HTTP.
Without relying on things like in-memory encryption or, God forbid, homomorphic
Hopefully next
encryption.
year we'll have another section on here.
Exactly.
Get another
and then now that we've got a quantum computing service, you can try and break Shor's algorithm or create Shor's algorithm on the quantum computing service to break your cloud HSM and get back in when you fat-fingered the password.
Other questions? Yes. So clusters are regional constructs, but you can do cross-region DR. What you do is you clone a cluster. So you take a backup, you copy it to another region, create a cloned cluster there, and then you have a number of different options, whether through wrapping or through masking, to get your key objects from one region to another. You do have to do that synchronization manually, but it can be programmatic under certain circumstances or scripted under others. But you would do that. We don't do cross-region DR, at least not yet. I will, absolutely. Sorry, he was asking how to do cross-region DR for clusters. Yes?
So right now I'm using classic HSM because the algorithm required like what I use, but it's supported by the newest version of HSM. I'd like to know if now these algorithms are covered. So specifically there would be the KDF list and CMAC if you were missing.
So KDF from NIST, if you mean the HMAC KDF? Yeah, that's the HMAC KDF. We shipped that. We shipped that about 3 months ago. We shipped HMAC KDFs, the SP 108. CMAC is coming early next year. So be patient with us, it's on the way. Just make sure that I know that you're waiting for it, and I will send you early access as soon as I can.
Because I understand the classic HSM is then going to be end of life like early next year.
Yes, so Gemalto has declared end of life for the Luna 5s that were in the first generation. And I think I know which company you're with. We've actually signed an extension with you, so you should be fine. Yeah, you'll be fine. We're watching out for you.
How's that for personal service? Yeah, you know.
No, we worry about our customers.
So the question was about this gentleman is on the Cloud HSM version 1, which was the SafeNet's Luna, and we sent all of her customers messages saying, please now migrate to version 2. And Avni hand manages these to help the customer experience
It's all
along
good.
the way.
It's all good. Questions? Any other questions? All right, I'm going to skim through these slides to see if there's anything else we need to cover. We covered KMS, we covered architectures. Half the problem is like I cover everything before I actually get to the slide. Oh, performance, cost management. So you don't have to pay for all your HSMs all the time with Cloud HSM. Please remember that unlike traditional HSMs, you can delete them, they will save state, and when you recreate them, they'll pick up right where you left off. So when you're doing dev test, if you're one of those companies that actually goes home on the weekend, turn them off on Friday, turn them back on Monday, you've cut your costs by 40%. If you only issue certificates once a quarter, don't have your HSMs, don't even have your clusters for the rest of the quarter. Like just spin them up when you need them. The backups are stored for free. Right? If you need escrow across regions, just copy the backup across the region. You can spin up a clone cluster anytime you want. The backup is free, the copy is free. You don't have to pay the $20,000 a year just for cross-region DR. So really, really look at how you can leverage elasticity in order to save costs on Cloud HSM. And then the last thing I wanted to cover was we now have key store. So anyone who wants to do doc signing, jar signing, any kind of signing operations on Linux, we have released a key store that handles certificates transparently. This has been a pain point for many of you over the last year. It's there now. We do support blockchain. We have HMAC key derivation. And we also have compatibility with Lambda. So if you're trying to use your HSM in serverless configurations, you can now run run the client daemon in Lambda. It's not perfect. We'd like to get rid of the daemon altogether. But for the time being, at least you can make it work. And then for those of you who use resource-based policies, RBAC is coming shortly. You will be able to tag backups. You can already tag clusters, and you will be able to write policies, including tag on create, for clusters, backups, and HSMs. So with that, thank you for coming. We still have a few more minutes for questions. We're going to hang out outside. And
what I'd say is that now that you've listened to that, go back and watch the first part again and think, could I still use one of those AWS crypto services? And maybe I don't need a Cloud HSM after all.
Squigs are never say die guy. Like he's are there any final questions? Anything we can answer for you?
Gentlemen?
Just real quick, this morning there was a discussion like you brought up JavaScript, Java, and Python exporting. Do you have a roadmap timeline for Golang support on the SDK?
So we're looking into it. We do want to make the HSMs easier to use. CloudHSM in general has a tenet of being compliant with industry standards. And there's really no Go standard for HSM access. There are Go interfaces to PKCS11, just like there's PyKCS11, which is Python to PKCS11. That said, we are open to the possibility of building our own SDK, which is an AWS proprietary programmatic interface to the standard HSM.
Is that the same for KMS as well?
No, so KMS uses the encryption SDK, which is a proprietary interface, which is essentially create key, delete key, encrypt, decrypt, right? That is available in a large number of languages, and the spec is open source, so there are open source projects in a number of different languages.
Right now, it's just the SDK is not supporting Golang.
Make sure that they know that that's something you're looking for. I'm sure it's on someone's roadmap.
Tell your AWS account manager you want it.
Yeah, that's the easy answer. Thank you. All right, please make sure you rate the session before you leave. Again, thank you for coming. Wish you a very happy
thanks,
reInvent.
everyone.
Don't forget to replay tomorrow.
Thank you.